Okay, so we're going to go over what I messed up on earlier today. So basically there's two ways where we can take our data that we have from Simulink and how we can import it into Matlab. So I was kind of combining these two methods, and when you combine those two methods, it's not going to work out for you. So first I'm going to run my code here. Then I'm going to open up my Simulink model. Okay, so this is opened up. And I'm going to take a look at our two workspace blocks that we had. So I'll just click on this one. And so you see I have the variable name. And this stuff we're not going to worry about. But if we look at save format, right now it's a time series. And that's fine. But we can also save it as an array. So first off, I'm going to leave it like it was by default and saved as a time series, which is what we had in class earlier today. So earlier today, I was trying to run this code. I think this is what I had right here. So if I ran it, and then I went to time_mf, which stands for time corresponding to our maximum force, then it's a 0 by 1 double, and our value is what? It's nothing. There's nothing there. So that was an issue. Basically what's going on here is if I go to out, and then I go to sim_force, I have a double here. I have a however many columns by 2 array. So I have 2 columns here. But in my code, I'm not specifying what column to look at. All I put is out.sim_force. So Matlab is going in here. It's going to sim_force, but it's like, what the hell, man? I don't know what column you want me to look at, so I can't do anything. So all we have to do is do .data, which if we look at our structure here, we see that we have a column called time, and we have a column called data. So the column for data, that corresponds to our force. So we need to put .data. Now if I run this and I go to time_mf, then we see that it has 1.8, corresponding to 1.8 seconds. So I'm going to break down this code right here. So we first found our maximum force, which is just the maximum force that's corresponding to our output for the simulated force. So we found that was 8.19 times 10 to the third. Okay, so in this block of code here, let's look at this line. So we're saying to find the maximum spot, or we'll look at the comments here. Find the index when the maximum force occurs. So I want to find that index. I have, let's go back here. So I have our array here. So it's a whole lot of stuff. So I'm saying find the index, or find the row that our max force occurs on. And I'm telling it to look in this column for data. So it says, okay, assign a variable called max f spot, or the spot where our maximum force occurs. You're going to find this by looking at this array here, which is called out.simforce.data. So it's only going to look at this column right here for data. And give me the array, or the position, when I have a value that is equal to max_force, which is what we defined up here. And that's, 8,196. Okay. So once we run that, it's going to give me that spot, or that index, which we look here, max_f spot, that's 181. So if I was to go to row 181, let's say it was this, it's not this, but let's say it was. It's going to be row 181, that's going to correspond to the index when we had our maximum force. So one of the questions we have is, when does this occur? What time does that maximum force occur? So I have a new line of code, time_mf, so the time when our maximum force occurs. And now I'm looking at a different array here. It's called out.tout. So we're going under this structure here called out. And then you see we have an array here called tout. This just corresponds to our simulation time, which is 25 seconds. And remember, we used a fixed step size of 0.01. So that's this array right here. So I'm now in this line, I'm saying this time when the maximum force occurs, we're going to look at that array that we just looked at, and we're going to use the index when our maximum force occurred. So that's index or row 181. So we'll go back to tout. So I only have one column here, so I can actually delete that comma 1, and I can run it, and that's still going to run fine. The comma 1, that just meant look at column 1, but since I only have one column, it's a column vector, I don't need to specify that. Okay, so we could write all of this code here, these two lines of code, more compactly, and this line. So we can say, you know, time underscore mf and time underscore maxf, they're the same thing. I'm just solving for that time when the maximum force occurs in a more compact line right here. So I'm saying, okay, let's look at the column vector for time. So this column vector here. And then you're going to match up the index for, or you're going to first look at that array for the force data, and then you're going to give me that index that matches the index for max underscore force, so for that maximum force. Okay, so that's just a more compact way that we can write it. Okay, so now we're going to go over the other method that we can use for exporting our data from Simulink into Matlab. Okay, so I'm going to open up Simulink here, and I'll look at the maximum force to workspace block that we have. So if I double click on this, then here's our name, and here's limit data points and decimation. We're not going to worry about that. But where it says save format, by default it's a time series format. So it has a column for time and it has a column for all of our data. I'm going to change this to array, and then it's only going to output an array for our force data. So I'll click apply, click OK. I'll go out of here, and then I'm going to run my code now. And now if I double click on out, on this structure called out, now you see our sim underscore force, that's a 2500 basically by 1 double. So that's an array. It's a 2501 by 1 array. We have 2501 rows and 1 column. Everything else in here, you see it has a little clock on it. That's because it's a time series. So let's actually go ahead and we'll change all of these to be outputted as arrays. So, sorry if you can hear my stomach growling. Sorry, it just won't shut up. Yeah. So on my computer right now, it's still storing everything inside of out. But on my laptop, I'm doing the same thing here, and it's storing all of those two workspace blocks that that we exported from Simulink. It's storing them as its own variable. Let's actually, I think I might know why. No. Okay. Yeah, so I'm actually just checking my script right now on the other one. So yeah, so on my laptop it's storing everything as its own variable. So it's storing sim underscore force as its own variable in the workspace. So I can get a little crowded. And yeah, and everything else is the same for the code. Like I'm assigning a variable called out for the simulation that we're running for the model. So anyways, let's do that. First what I'll do is I'll uncomment this. So we still need to do out.sim underscore force because the simulation for the force, it's still stored under out. Okay. if it wasn't stored under this variable called out, then I would have been able to do just sim_force, which is what I have on my laptop. But since that array is stored under this, I should say structure out, we need to do out.sim_force. So if I run this code, then we see that's our maximum force. Let's uncomment this. So at this point, before we had this .data part, now I'm going to take that out because our array here for sim_force, that only has one column. So let's run this now. I'm going to change this to time_mf. And then we see we have an output for 1.8 seconds. So let's go back to Simulink and let's change all of our 2 workspace blocks to export as arrays. So array, okay, array, okay, array. We already did it for force, so we have an array. And then for our elongation, let's make that an array as well. Okay. And we're back here, we can run it. Now let's double click on out. And now you see that all of these are arrays. They're all column vectors in this case. Alright, so there we go. So now we have our maximum force and when it occurs for our first cable here. I want to check something really quick here. Alright, yeah. Just making sure for something. We're good. Alright, so now let's do this for the second configuration. So for the other stuff, when we have 2 configurations, I might have you write that code on your own for the second configuration part. So we'll do max force 2. We're going to do max out dot I know, yeah, I kind of forgot something here. So we have our second configuration. So what we can do is go into Simulink. So this is for configuration 1. Let's make a little, no, I don't want to search. Oh god. Alright, let's open up Matlab again. It just crashed on us. I think that's the first time it crashed for me on this computer. Alright, so it's gonna do the simulation. It's gonna take a little bit right now. So basically what we're gonna do right now though is we have our first configuration for Simulink. Now what we could do is we could run all the simulations for the first configuration for the first cable, and then we could change our value for K to correspond to the second cable. That's not very efficient though, so let's open up our Simulink model. Okay, here we go. So I'm gonna write config 1. Let's make this larger. Okay, so here's our configuration for the cable that is a length of 300 feet. And there might be a better way to do this too with like some logical operators, something I should look into. But all I'm gonna do right now, just for simplicity, and I'm sure there is a way where we can just use some logical operator where we can say either use K for the first configuration and or use K for the second configuration. But for now, we're just gonna copy and paste this and we'll do configuration 2. And now all we're going to do is change our K values here to K2. Now we haven't defined that yet, or actually I think we have. Come on, let's go. Can you not? My computer is freaking out. There we go, jeez. Alright, so I'm going to change that to K2. Click apply and OK. And yeah, that's just C divided by M, and then we'll change this one to K2. Click apply, OK. We'll change this to K2. Apply, OK. Now I think I got everything. K2, K2, K2. Alright, so there we go. So now we have... I just changed that for the first configuration. Maybe some of you are screaming at your screen. This should just be K, yeah. K2. 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 Alright, there we go. Now let's run this. So, yeah, again, more efficiently, we could use some logical operator. And that would save on memory, but you know, for this kind of model that we have, it's not that complex. So we're going to leave it like we have it here. And so I need to change some of these. Yeah, okay. So I'm going to change this to underscore C2 for configuration 2. And we want it as an array. Sim underscore velo underscore C2. Save it as an array. Our position, sim underscore position C2. Save it as an array. Sim underscore force underscore C2. Save it as an array. And one more. Sim underscore elong C2. Save it as an array. There we go. Gonna run our code now, and now if I go into out here, oh boy, it reset some stuff. I think it reset some stuff when it crashed because I didn't save stuff in time. I want all of these as arrays. And then we'll make sure to save the model. Okay, save the model. Run the script. Now if I double click on out, now we see all of these are arrays. So good. Alright, so max force config 2. Let's do that right now. So we have max underscore force underscore 2 max out dot sim force underscore C2. That's what I did, right? Yeah. Okay. And we could put another comment, find maximum force. Cool. You know, you don't need to put all of these comments like I'm doing. In fact, it'd be better to... No, let's actually do this right now. I'm going to put the two configurations kind of side by side. So maximum force. So max force for configuration 1 and then configuration 2. I'm gonna move this code up here. Okay, this is for configuration 1. And we'll copy this, paste it. There we go, C2. Run. Alright, so we have our maximum force for the first one is 8,196. Max force for the second configuration, 6,402. The time when it occurs for the first configuration is 1.8 seconds. And the time for the second configuration is 3.93 seconds. Cool. Alright, just making sure it's recording. Alright, now we have, we can delete this, the elongation, so there's nothing that we need to calculate here, we're just making some plots. Now we'll do the max velocity for both configurations. Alright, so we're going to do the kind of same thing that we did above, so we'll do max velo equals max out dot sim underscore velo. Okay, that's going to be our maximum velocity. And then we'll do, we'll find the time when that occurs. Or we'll do max velo 2 as well. We have to do that. Let's run that, make sure it's working. It's working. Nice. Let's rename this to just velo. And we have max velo. Time for max velo. Time. MV for max velo. Out.tout. Out.sim underscore velo equals max velo. Okay, so again I'm saying give me the time when we hit our max velocity, and we're doing that by matching the index position that we have for our velocity to the index for the time. Okay. And then time underscore MV2, I could copy and paste, oh well. And C2. Reference to non-existent fields, so sim velo underscore 2. Oh, I did C2. There we go, let's get all of our variables in store here. Alright, so time for our maximum velocity for the first configuration is 2.75 seconds. For the second configuration, 5.24 seconds. Very nice. Alright, now we are on, what are we on? Let's check. I guess we're in plots now. Let's see what we need to plot again here. Let's see, where did I put this? Labs 1, deliverables. FBD, we got that. Equation of motion, we got that. Analytic solution, you work on that yourself, have fun. Maximum force in the tow cable when it occurs, both cables, we got that. Some exciting stuff to answer in your lab report. elongation in the tow cable due to drag. At steady state, we got that. That's it's gonna be a plot. So what else? Comparison of elongation at steady state using both cables. So we'll come back to this. Maximum velocity of the submarine and when it occurs. Got that. Length and cable stiffness of cable 2. We calculated that last class. Some more stuff to talk about in your report. Okay, expected plots. So force versus time for both cables, elongation versus time, both cables, velocity versus time, both cables, and then our analytic versus Simulink models. Okay, so I'm not going to be showing you that. That's something you'll do yourself. I will be uploading the Matlab code for our example ODE so you can see how to kind of implement that code. And you're going to compare graphs for position versus time, and velocity versus time, and acceleration versus time. I believe this is going to be for the first cable. So for the cable that's 300 feet, you're going to compare that analytic versus Simulink solution. Alright, let's go back. You know what? We'll go to the model, Simulink model. So we want to show you how to do the other method for the elongation. So let's go back here. Gotta open up my slides. And elongation. Oh, I could have opened up the slides from today. Oh well. Alright, so this is the other one that we want to simulate here. Delta x equals c times v divided by k. So let's do that right now. Alright, yep, just checking that. Okay, let's do it. So I put, in the other model I put it over here, which seemed a little weird to me. So I'm gonna put it down here this time. So right now we're on the first configuration. We wanna model the elongation using this other method here, where we're taking the damping into account. So remember, at steady state, this solution is going to be the same as this solution here. And you're going to explain why it's the same and why it's different for the transient response. So we need a gain block. Thank you. Yeah, okay. So c divided by k, this is what we need. Apply. Okay. Cool. Okay, now we need the output from our velocity. This is probably why I put it over there before. It's gonna be a little weird. Okay, so right there, I just right-clicked on the branch and then I could drag it out. It's like I'm playing Snake. I don't care. Alright. And there we go. So we have c divided by k multiplied by our velocity right there. Cool. Now we want to see that output. Get a scope. I'll move this. Oh god. That's terrible. Just ruined it. Come on. There. Okay. Scope block here. I want to move this up. Cool. Elongation 2. That's fine. I'm going to make a little annotation here. So elongation equals CV divided by K. just so we know what we're looking at. And we'll copy another 2 workspace block, plop it down there. Then we'll do sim elong, and then we'll do M2 or method 2. Why not? Let's run this. Then I can look at this output. Let's compare these actually. So here's our first method here. And then we'll look at the second method. Alright, so our second method, we see that the damping goes up to, I don't know, let's say it's like 4.35. And on the first method, sorry, not our damping, our elongation. In the first method, our elongation almost goes to 5. So you're going to explain why in the end. But once we go to steady state, both of these are going to be around the same. And we can check our output as well. So let's actually quickly do that. We'll go back into Matlab, we'll run the script. And then if I go to out, Simulink M2, here we are. And then we can see our output here. And then see we're at steady state now and we're hanging at around 3.6. It's pretty much 3.6. I guess really steady state is 3.59999. Okay. So let's go ahead and do this as well for the other model. So all I have to do is just copy and paste this. So I'm going to right click and drag. And let's try to match it up a little bit. Alright, let's attach this. There we go. So now I'm going to rename this to C divided by K2. And now I need to change this to K2 as well, because we're looking at the second configuration. Whatever, leave that the same, and then sim elong C2 M2 for configuration 2 and method 2. Okay, save it. Back here, run it, look at it. Cool. Alright, so yeah, okay, plots. I can finally go to the plots. What do we gotta do? Force. Force. Yeah, whatever. Alright, so we need to plot force versus time. So we're gonna do plot. We need to do plot x comma y, so our x domain is gonna be t out. That's our simulation time. So plot t out, comma, out dot sim underscore force. We're going to plot all the data that we have for our force. And okay, I made this a blue line, and I changed the line width to 2. Maybe I'll do 1.5. Let's run this. I need to out.tout. Out.tout. Alright, there's our force graph or config 1. So I'll do present C1. Alright, hold on. So we want to do another plot. So we do hold on. Out.tout. Out.sim force underscore C2. We'll make this red. Yep, red. Line width 2. And config 2. Hold off. Run it. What was the error? Here. Okay. Okay, thought it looked a little weird at first, but no, that's right. There we go. Let's put a title on here and our labels. We'll do an X label first. X label, just time, seconds. Time, second. Then we'll do a Y label. What did I put? Force. Pound force. Alright, I thought I used LaTeX formatting, but I guess I didn't. It's fine, you don't need to. Yeah, I don't think you will. Okay, title. I guess we don't really need to have a title, you just need a figure caption. Okay, you need that for sure. That'll be below your figure in the lab memo. Alright, we need some legends. Or one legend. So the first argument for our legend is going to correspond to our first plot. So that was cable 1, 300 feet. And then we're going to do cable 2. Oh man. What's the length? I'm just going to put 695. There we go. Yeah, let's run it. Oops. Okay, so you can change the size of the legend if you want, you know. Look it up if you want to change it. I didn't change it. Let's see. Location. Northeast. And then legend box off. That's going to disable the box that we have. What did I do wrong? There's a formatting issue. I need to put in quotes. Alright, there we go. Cool. Nice. Alright, velocity. We need force, velocity, elongation, right? Force, elongation, velocity, okay. I'll just do velocity right now. So, oh, you know what, we need to add up here, figure 1, so now we're adding another figure, and we don't want Matlab to write over anything, so figure 2, plot. Out.tout, out.sim underscore velo. Is that what I have for the first one? Yep. Yep. Should have copied and pasted. I kind of like typing too, I guess. Velocity, feet per second. I don't need that there. Okay. Legend. Cable 2695. Yep, really should just copy and paste. One graph. Oh, that's our velocity. Cool. Alright. So, maybe you want to put a caption, I don't know. Or, you know, a title here. You do need a caption in the lab report memo. And elongation. Oh yeah, so we're gonna have a few plots here, actually. Figure 3. So I'm gonna do method 1. Okay, so first we'll do it for method 1. Plot out.tout out. Sim underscore elong. Was that it? I already forget. Yeah. Hold on. Red. C2. C2. Hold off. Run it. Cool. I don't need you. Controller. X label. Time. Seconds. Y label. Let me move my keyboard. Alright, Y label. Elongation. Oh boy, what are the units for this again? It should be in feet. Right? Can you run? Yeah. Okay, it's in feet. Just want to be sure. Yep. Legend. Yeah. Legend box off. Okay, yep. See, now we need to change it. We'll do southeast. Better. Method 2. Figure 4. M1. I'm at M2. Okay, so now we've changed it to look at the second method. And we're just changing, you know, a few things to change it to the second method. And, yeah, that should be good. So, you know, in this case, I would maybe want to have, again, you should have a caption, but for the sake of this demonstration here, I'm going to put in a title. Well, if I can type. Okay, yeah, they just look so similar because they're not on the same plot. So let's do them now on the same plot. Methods 1 and 2. Figure 5. Blue and cyan. To see what it looks like. C1 M1, C2 M1. C1 M2, C2 M2. Hold off, and then we're going to put our X labels in our title, in our legend. Okay, so title, cable elongation, comparing methods. Legend, cable 1, 100 feet. I don't want it to be too long for the, yeah, you know, for the legend here. So maybe you want to change, you know, what you're writing here. Yeah, I'm just gonna think of something better on your own. But C1 M1 for cable 1, method 1. C2, yeah, C2 M1. Okay, so that's the first two plots here. They were both using method 1. Now we'll do C2 M2. Nope, C1 M2. Cable 1, method 2. And then cable 2, method 2. And we'll make these green and green and magenta. Okay, yeah. Yeah, I guess it's fine. And I'm just kind of thinking about it. Oh, let's fix this. Okay, so we have blue and we have pink. Oh, sorry, cyan and pink. So we have cyan, that's cable 2, method 1. And pink, cable 2, method 2. So yeah, our transient response is different for the elongation, but in the end, with both methods for cable 2, our elongation is the same at steady state. Yeah, you might want to make this legend a bit better so it's easier to just look at the graph and then look at the legend. And then we have green and blue for cable 1, and then we have two different methods, but transient response is different, and then the steady state response is the same. So if you're going to have only one graph for the cable elongation, comparing everything, I would have this graph. It's so much, you know, better to compare it this way. Although, let's see. I guess I'm not decided, but I would recommend putting all three graphs here that you see now for the elongation. But if you're only going to have one, make sure you have this one here. That compares everything. Alright, get out of here. Make sure you just have this one if you're only going to have one. Alright, so I think I covered everything that we needed. This was pretty long too. That would have been like a 3-hour lecture. Damn. Force versus time, we got it. Elongation versus time, got it. Velocity versus time, got it. I guess we didn't plot any acceleration here. So you're going to be plotting the acceleration from Simulink versus your analytic solution. But let's do that. Obviously, I'm only going to show you the Simulink one. Did I even have one for that? Yeah, I did. Figure 6. Plot out.tout, out.sim. Excel. B. Line width. 2. cable 1, x label time seconds, y label Excel, I can't type, acceleration, feet per second squared. So in this case, you want to use some kind of math interpreter to actually make your formatting good. I don't want to see formatting like this, where it's S with a hat and squared. It looks bad, so I'll fix that in a second. Don't need a legend, I guess, so let's run it. Here's our acceleration. I think our max force occurred then. Alright, so think about it. So I need to do... Let's hope I can remember how to do this on the fly. So time... I'm gonna do... $sign, $sign... $sign. So in LaTeX, if you're doing math in line, you need to wrap the math that you're typing out in $signs. So I will want to do a fraction, so \frac. I'm going to do the top, so feet, and then second squared in the bottom. And then I'm going to do interpreter. Cannot type LaTeX. Okay, hopefully I remembered that code correctly. Nope. Well, I did over here, it looks like. Oh, yeah. See, I was thinking this was just one line, but it's really not. It's like this. Interpreter. LaTeX. There we go. There we go. So we have time, second, and then acceleration, feet per second squared. That's pretty small font. So I would maybe increase the font size. And I kind of forget off the top of my head. I don't know if you need to do it like that, font size. Oh boy. Am I right? Nope. I don't think that worked. Go crazy. Oh, that was right. Wow. So yeah, Matlab has like you know, it's case sensitive for this kind of stuff. Yeah, it's better. I would maybe make I don't know, this still looks a little weird to me, so I would make that look a bit better if you're doing it. Oh, I need to wrap it in parentheses as well. So when you have a fraction in LaTeX that has a numerator and a denominator, we need to do it like this. So backslash left, backslash right. There we go. Alright. So I'm going to end it right there. Well, hope you enjoyed basically lecture number 5. That's essentially what this was. If you have any questions, go in the Discord or email me or whatever. Alright, see you all on next Tuesday. And I'll put up the due date for this sometime today too. Alright, see ya.